Could the sun have a binary companion? Are we the only observers in the universe? Will lunar bases be close to each other? And in Q&A Plus, could we grow crops in asteroid regolith? All this and more in this question show. It's time for the question show. Your questions, my answers. As always, wherever you are, across my channel, if a question pops in your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Santiago T75, would it be possible for the sun to be orbiting another star and perhaps we haven't noticed it yet due to the sheer cosmic scales and distances? So this is an idea that people have had in the past, that the sun was in orbit, a very wide binary with some other star. And we see these wide binaries out there in the cosmos. They can be tens of thousands of astronomical units apart from one another. And it's kind of surprising how faint a red dwarf star or even a brown dwarf would be in the sky. That, you know, the closest star to us is Proxima Centauri, and yet you can't see it with your eyes. If you walk outside, you cannot see the closest star to us. You can see Alpha Centauri, it's very bright, but you can't see Proxima Centauri. And it's a red dwarf star that you would need a small telescope or, you know, a good pair of binoculars to actually pick it out. And that's all you could pretty much see with your small telescope. You know, there aren't many red dwarfs that you'd be able to see because they are so faint and you can't see any brown dwarfs. Now there's a couple of tools that have come along who have been able to sort of give us a firm answer on this question. The first one is the WISE telescope. And this was a space telescope that was launched 15 years ago. And it was doing a wide infrared survey of the sky, looking for things that are bright, glowing in the infrared spectrum, but not necessarily bright in the visible spectrum. And so, you know, it's looked at all kinds of things, but one of the specific targets that astronomers were looking at is, are there any giant planets like Jupiter's in the outer solar system? And are there any brown dwarfs in our vicinity that are in orbit around us? You know, there's this classic idea of this nemesis, right? Or planet X that, you know, what if there is a, you know, some other companion object to the solar system that's on this really wide binary orbit and comes back every few million years and devastates the Earth because its gravity messes with the Oort cloud. And so the WISE telescope was able to rule out, like literally, if there was a brown dwarf in our vicinity that was interacting with us, it would have been detected by the WISE instrument, and it wasn't. And we know that it actually ruled out Jupiter-sized worlds within about 10,000 astronomical units of us, which is really far. You know, like say a quarter of the way to Proxima Centauri. So we now kind of know that there are no giant planets in the outer solar system. And so that's why when you think about, say, Planet 9, it has constraints about how big it can be. It has to be sort of Earth-sized, maybe Neptune-sized, but if it's Earth-sized, it can be closer. If it's Neptune-sized, it has to be a little farther because those are the constraints that WISE has already set. And if there was like some future infrared survey that was done of the sky, then we could set those constraints even tighter. So that's the first tool, is WISE. The second tool is Gaia. And this was, you know, my favorite mission recently, up until Vera Rubin came online. And this is the European Space Agency's mission to chart the positions and the movements of about 1 billion stars in the Milky Way, including especially all the ones that are nearby. And so we have incredible motion data. Just to give you sort of a sense of the capability of the Gaia mission, it could measure the position of a star to the width of a human hair seen at 1,000 kilometers. Like, just let that sink in. You take a human hair, take it 1,000 kilometers away, and then that's the resolution that Gaia can provide. And so it knows with exquisite precision the movement of all of the stars that are in our vicinity, and none of them appear to be in orbit around us. In fact, what Gaia did was it found probably some of the siblings that the sun formed with, that it actually detected stars that have the same kind of movement through the Milky Way as the sun and the solar system does, and has similar chemical constituents to the sun. So we are definitely not in a multiple star system, and we have the tools, we have the receipts. Silas Miller. Are we really the only true observer of everything in the universe? That truly terrifies me. We don't know. So either we are the only advanced civilization in the universe capable of observing the cosmos, and only we know the sort of true scope and scale of the universe, or there are many civilizations out there across the cosmos, and they have their versions of astronomers, which seems like a thing that you would eventually develop. Now, they're observing the same kinds of things that we are. They're observing planets and stars and galaxies and quasars and black holes and all this kind of stuff. But maybe they have different wavelengths of light. Maybe they, their eyes work in a different way. And so they sort of think about the universe in different ways. And maybe they've made a lot of discoveries about the fundamental nature of reality, about physics, chemistry that we haven't made yet. Just because, we come at our discovery and our science from a very specific perspective. I just finished reading Children of Time by Adrian Tchaikovsky, and the protagonists of the book are spiders and humans. And the spiders are advanced and intelligent and eventually develop astronomers and technology and radio and all this kind of stuff. But it's all very spider-based. So they think in terms of webs. They build out of certain kinds of construction materials, and they make some, mathematics comes very easy to them, while the humans have other things that they're good at. And the sort of the humans and the spiders meet and interact and realize how much they have they're understanding reality in sort of the same way, but they have different things, different strengths that they bring to the table. So it may very well be that the different civilizations sort of perceive the universe in different ways just because of what evolutionary pressures were out there. So, it's back to Arthur C. Clarke's famous quote, right? Either we are alone in the universe or we're not. And either possibility is equally terrifying. It's time to shout out all the new $5 patrons and above: Paul Schackenberg, Meg P., Andrews Ellison, Smurflet42, Todd Lechner, Caroline Webster, Marco Van Leishout, Joe Reynolds, Charles Nutter, and William King. Join the club at patreon.com/universe today. Terry Hardaway, how hard would it be to put the ISS into lunar orbit or even on the moon? It would cost all the money. So I did the math a couple of years ago, and the thing to always understand is that to go to the moon is not like you just drift away to the moon. The moon is at the top of this enormous gravity well. Think about this feeling that you have when you try to climb to the top of a mountain, right? It's exhausting. It takes a lot of energy and effort to get to the top of the mountain. Well, imagine your mountain is 500 kilometers high. That is the altitude of the International Space Station. And so when we launch stuff into space, we have to climb a mountain, 500 kilometer mountain tall, and go sideways 28,000 kilometers per hour just to be in orbit around the Earth. Well, the moon is on a further mountain. It is now a mountain that is about 400,000 kilometers tall. And so if you want to take the International Space Station, you have to lug it up that mountain. You have to carry it. You have to push it up that mountain. And that requires propellant. I did the math, and it depends on what you do. You use ion engines. Do you use starships? Or starships cheaper? Who knows? But you're looking in the roughly the same amount of cost that it was to build the entire International Space Station is what it would cost for you to send it up into lunar orbit. You'd have to match the investment. So you're looking at well over $100 billion in just fuel to just raise the orbit of the International Space Station. Now, if you want to land it on the moon, then the problem is that you can't do it very slowly and carefully. You have to, at some point, have a lot of rockets that are allowing you to decelerate gently onto the surface of the moon. And so you would have to launch hundreds of rockets that would be capable of carrying different parts of the space station and be able to balance the forces as it's getting closer and closer to the moon. So it would cost, again, probably the cost of building the space station in the first place. You'd be looking at hundreds of billions of dollars to have it land gently on the surface of the moon. You'd probably send up starships. You'd break open the International Space Station. You would chomp down on the different modules. You would put them inside Starship. You then refuel your Starship. Your Starship would fly to the moon. It would land on the surface of the moon. A crane would pull out the module, put it down gently on the surface of the moon. Yeah, you're still looking at hundreds of billions of dollars to try and do something like that. Space whales. How close do you think the Chinese base on the moon will be to the American base? Seems like there's a lot of benefits being close, geopolitics notwithstanding. Any base on the moon is probably going to be set up near the permanently shadowed craters of the moon at the South Pole. But there's a lot of those craters, and there's plenty of places that are ideal. There are hundreds of good spots to build base, and they're going to depend on how close you want to be to the potential frozen water, how much energy you need to get, what are some interesting scientific sites that are around you, how is the safety, are there landslide risks, how easy is it to move around on the surface in the region where you want to set up. It's not like you've got all of planet Earth to set up. You've got your areas that you can set up your moon bases on are filtered down from a large list, but it's still lots of space. So how close would they be? I mean, I would think it would be great if they were very close. If you've watched For All Mankind, the Americans and the Russians set up their bases very close to each other, like within walking distance of each other. And, that's to set up tension and conflict in the show. But I still hold that the International Space Station was one of the greatest ideas that's been had in spaceflight, that you took two enemies, the Soviet Union or the Russians and the United States, and then all the other countries in the world who participated, Canada, Japan, right, Europeans, and had them come together to build this space station in peace. And so even if people are in conflict down below, they're working together like a team, which scientists and explorers will. That if you set up one base and you had it staffed with some Chinese and some Americans and some Europeans and, the occasional Canadian, they would work in harmony. It would be great. And that it would save in transportation. It would save in risk. It would be the ideal situation. And I hope that's what happens, because that's, I think that's the right play, is to build together. But politics on Earth will transcend and go to space. Nunya, what sort of internet bandwidth should we expect on our moon bases? It won't be great. So the first issue is the ping times. So it takes about a little over a second, 1.3 seconds, to send a signal from the Earth to the moon. Kind of depends on where the moon is at its orbit. So if you want to do the round trip time, 2.5 seconds for you to be able to communicate. And so you want to click on a web page. It's going to take you a couple of seconds for that web page to start to load, no matter what. But imagine you're trying to play a video game. You're trying to play some first-person shooter, and your ping times are 2,500. That'll be brutal. You don't want that. You want 0.15, right? The other issue is that it requires a bigger and bigger transmitter to be able to send that great distance. But there are some new technologies that are being tested in space. NASA has a brand new communication system which uses an infrared laser to transmit data back home to Earth. And they're able to achieve broadband speeds from tens of millions of kilometers away. So we will probably have arrays of infrared lasers on the moon that are transmitting communications from the Earth, and then the reverse on Earth transmitting back up to the moon. And they'll have dishes, they'll have telescopes essentially that are receiving the signals from those transmitters going back and forth. And so the more bandwidth people are trying to send from the Earth to the moon, the more that they will build more and more of these receivers and transmitters on both sides. It'll be lasers for sure. Did you know that you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call it Q&A Plus. And this week's bonus question, could we grow crops in asteroid regolith? And I'll put a link in the show notes. All right, those are all the questions that we had this week. Thank everyone who joined me for the live show. Everybody who put your questions into the YouTube comments. I really appreciate it. The new season of One Piece is out, and I'm going to give you my thoughts. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Bergetti, Bear Lake Roofing, Brian Bodie, Carolyn, Chuck Hawkins, Commander Balak, Cooper Nelly, Darkfinger, David Gilton, David Matz, Evan.Pro, Greg Feely, James Clark, Janice Smith, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Marcel Smits, Michael Purcell, Nordspace, OneStepForAnimals.org, Renkaidu, Richard Williams, Sean Sargent, Stephen Falamonley, Team 49, Telescopes Canada, Wolfgang Klotz, and Zeldabor Galactic Defender, who support us at the Master of the Universe level. And all our patrons, all your support means universe to us. So last week, we had the second season of One Piece on Netflix, and I enjoyed the first season, but that was before I had watched much of the show. And since then, I've watched about 500 episodes of the One Piece anime. And so going into the second season, I was a lot more prepared for what I was watching. I understood a ton of Easter eggs, and I really enjoyed the show. You know, my wife was on the fence. I think it was a little too weird for her. And, all of the sort of anime references and things, they all just sort of flew right past her. But for me, I thought they did a fantastic job of trying to boil down what is one of the most epic pieces of literature ever created. Like, it's a monster. Like, just in terms of sheer mass, there is a lot of story here. And I can't even imagine how hard it's going to be to try and break up the story into all the different episodes that they're going to have to do. And we got sort of through a lot of chunks. We're sort of leading up to the battle for Alabasta, which is a whole other chunk of the One Piece show. But I enjoy how much of the weirdness of One Piece makes its way into this show, the amount of creativity. And it was funny because I was watching the show with my wife, and it was a whole episode with Lebu, and she says, "Oh, I see what's going to happen here." And I'm like, "You do not know what's going to happen here. Like, I promise you, this show is so weird and so creative that you have no expectations." And I think that's one of the things that I just really enjoy is that a lot of it is just so weird and so creative and so clever and so different that you don't have any firm ground to kind of compare it to. It doesn't fit into a lot of the memes that you're familiar with. And yet there's a lot of stuff that I am very exhausted with in One Piece. That's why I know there's a version of One Piece called One Pace that you can watch it kind of clip down with just the important pieces, because there's a lot of filler in it. And there's a lot of tropes that are bad in it. A lot of kind of misogyny and, other stuff that I'm really kind of glad has not made its way into the show. So overall, I'm really happy with the adaptation. And, I don't know how they're going to try and keep this going for season after season after season, because these kids are getting older, and yet in the actual show, they don't age because it's really just over the course of a couple of years. So, but I guess there's the time skip. Anyway, I enjoyed One Piece season 2. If you haven't watched it, go watch season 1 and then watch season 2. All right. We'll see you next time.